today I will focus on a particular aspect of macroeconomic modeling, which is that of expectation formation. So this is the outline of the talk. My goal for today is to show you how laboratory experiments can be used as a complementary tool for policy analysis. For the sake of concreteness, I'm going to frame the discussion within a specific policy problem, which is actually a topic of current debate in the macroeconomic literature. And within this policy problem, I'm going to show you how the experimental approach can contribute to this debate. And I will highlight what is the added value with respect to the standard tools available to macroeconomists. And I'm also going to relate this to complexity, which is the topic of today's workshop. I'm going to discuss then briefly the experimental design, show you some results, and finally conclude. So the policy problem at hand. So as you all know, the control of inflation is central to good monetary policy. I think I don't have to explain you why price stability is a good thing. This is well understood by now, and that's actually part of the mandate of many central banks. Now, in new Keynesian models under rational expectations, which are the workhorse models for monetary policy analysis, inflation control, meaning the pinning down of a unique equilibrium path for inflation, is obtained through monetary policy satisfying the so-called Taylor principle. What is this Taylor principle? What does the Taylor principle say? The Taylor principle says that when the nominal interest rate, so the central bank instrument, reacts more than point to deviations of inflation from the target, then these models exhibit a unique equilibrium, which is stable and in its simplest form is simply equal to the inflation target of the central bank. And this equilibrium is often referred to in the literature as the forward stable equilibrium. Okay? The point is that recent literature on inflation dynamics has questioned the ability of this Taylor principle to uniquely pin down the inflation path in these kind of models. In particular, there is this paper by Cochrane showing that even if the Taylor principle is satisfied, there exist multiple rational expectation solutions which are non-fundamental solutions. They're explosive, but nevertheless, they are valid solutions in the sense that these are nominal explosions. They satisfy all relevant equilibrium conditions. So this poses a problem of indeterminacy of inflation, of multiple equilibria. Now, is this new? Well, no. Already Lucas, in 1986, made the point that recent theoretical work is making it increasingly clear that multiplicity of equilibria can arise in a wide variety of situations. However, he goes on by saying that all but a few of these equilibria are, I believe, behaviorally uninteresting. Why? Because they do not describe the behavior that collections of adaptively behaving people would ever hit on. I think an appropriate stability theory can be useful in weeding out these uninteresting equilibria. So that's a long quote. I'm going to, decided to split it in two parts. So let me first explain now why multiple equilibria can arise in this kind of model and why it makes sense to think about a stability theory as an equilibrium selection device. Expectations are central to economic modeling, and that's also the case for macroeconomic. In fact, modern economies can be thought of as expectations feedback systems, in the sense that economic decisions today, so describing the state of the economy today, which I'm going to call XT, depend upon expectations about the future state of the economy. So X expected for period T plus 1. Think about the decision of households deciding whether to buy a house or not. Well, they have to form expectations about their future income, future interest rates, and so on and so forth. Or think about firms that have to decide about pricing today. Well, they have to also form expectations about future inflation. Now, these kind of systems are self-referential in the sense that expectations today affect realizations, which in turn will affect expectation in the next period. So expectations and realizations of macroeconomic variables co-evolve over time in this dynamic feedback system. Now, in this kind of system, expectation errors, if not corrected, well, they may propagate through the system, becoming self-fulfilling or partially self-fulfilling. Just to give an example, to go back to our inflation control problem, suppose that economic agents coordinate on inflation expectations which are different from the target. Now, depending on the monetary policy implemented, these expectations different from the target may become self-fulfilling, so that actual inflation will be different from the target. Now, because people may coordinate on different inflation levels, well, this creates the possibility of multiple equilibria. However, what Lucas says is that, well, look, not all these equilibria are interesting from a behavioral point of view. And in fact, he advocates a stability theory calls, which is actually a theory of how agents learn and adapt in this kind of environment. Why? What is the rationale for this proposal? Well, if you want to think about an equilibrium as representative of actual aggregate behavior, well, agents in your model, they have to be able to learn this equilibrium somehow, either from past data generated by the economy itself or through some sort of reasoning happening in their head. And that's basically what the literature did. So I won't go, I don't have time to go into the details, but basically different scholars, they postulated their preferred learning mechanism, their preferred expectation formation mechanism. But the point is that the policy prescriptions you get out of these models, they crucially depend on the hypothesis you make about how agents form beliefs. Now, that's true in general. It does not only apply to this specific problem. So the literature didn't really reach a consensus, and this debate on inflation control is still open. Which takes me to the second part of Lucas' quote. So he said, well, you need stability theory. However, to be useful, the stability theory must be more than simply a fancy way of saying that one does not want to think about certain equilibria. I prefer to view it as an experimentally testable hypothesis, as a special instance of the adaptive laws that we believe govern all human behavior. So that's exactly what we aim to do. So we want to use laboratory experiments as a complementary tool for policy analysis, and in particular, so in this specific context, we want to empirically test for the effectiveness of this Taylor principle in pinning down inflation, so in ensuring convergence to the inflation target by means of lab experiments. What is the advantage over standard methodologies? Well, the clear advantage is that in the lab, you don't need to make any a priori assumptions on how agents form beliefs, on how agents form expectations. Why? Because these expectations will be directly elicited from incentivized human subjects participating in the experiment. So what kind of experiment do you need to run in order to study these kind of problems? These are called learning to forecast experiments, which is a design first proposed by Merriman and Sander in the 90s, which is tailored to study expectation dynamics in the lab. So the only task for subjects participating in these kind of experiments is to make forecasts of the aggregate variables that describe the experimental economy. In our case, these are going to be inflation and the output gap. And the reward will be only based on the accuracy of their forecast. So the better they forecast, the more precise their forecast, the more money they go home with. Okay? So then how does it work? Well, these are group experiments, so there's different subjects composing each experimental economy. In our case, we're going to have 6 subjects per experimental economy. Then, so all of these guys, they give their forecasts. Then there's a computer program which collects these forecasts, aggregates them, simply taking the average, and then it computes realizations of aggregate variable according to a mapping F, which is describing the structure of the economy. I'm going to be specific about the mapping used in this experiment, but this can be any preferred model you have in mind. Then what happens? Subjects observe these realizations, they can evaluate their performance, and this process repeats itself for 50 periods. The mapping F, so I've been told not to use equations in the slides. I'm using some, but don't worry, these are really your standard aggregate demand and aggregate supply equations. So the first one is really an IS curve that tells you that links output to expected future output, interest rate, expected future inflation, plus some little shocks. Then you have a Phillips curve that links inflation to the level of real activity, expected future inflation, and some shocks. And then you have the monetary policy block. Okay, so we have an interest rate rule which reacts to deviations of inflation from the target pi bar. Okay, and this reaction coefficient phi pi is going to play an important role, as we will see later. Now, if you plug this interest rate rule in the IS curve, you end up with a two-dimensional system defined by output and inflation. Okay, so this is a linear system. So the mapping F is completely defined by these matrices A and C. Why am I using this framework? The reason why I'm using this framework is that, well, first of all, it's really easy, it's simple to explain to subjects in the experiment, but most importantly, because I want to be able to compare results with previous results obtained in the literature. All the papers I mentioned before, they all use this simple economic framework. The only thing that we will be changing will come from these expectation channels. So expectations in this model will come from the participants in our experiment.
What is X?
X is a vector including output gap and inflation.
Okay, so that equation XT,
Yeah,
that's a vector equation?
that's right. So
Okay,
these are
for
matrices.
Output gap and inflation.
That's right.
Okay.
Where's the complexity in all this? Well, an important aspect of complex systems is that they consist of multiple heterogeneous agents interacting with each other. And one feature of this kind of system is that they display emergent microbehavior as the outcome of interactions occurring at the micro level. Okay? So the heterogeneous interacting agents here will be the participants to the experiment, and the emergent microbehavior will be given by the dynamics of output gap and inflation as the outcome of this interaction. Now, within this framework and given the specific problem at hand, which are the key questions for policymakers? Well, first of all, will this collection of heterogeneous interacting agents learn to coordinate on the desired inflation target equilibrium? And what is the role of policy? How can policy affect this complex coordination process? Now, before I give you details about the treatments implemented in the experiment, let me tell you a little bit about the instructions given to participants. What do subjects know about the economy they're participating in? What we do, we give subjects qualitative information about the economy. So they are informed about the function of the economy, the relation existing between different variables and expectations. So we basically describe them this model in words. What they do not know are the exact model equations and the exact values of the parameters and, of course, the forecast of other participants. So if you think about it, it's more or less this kind of mirrors what we know about the real economy out there. We have an idea about how it works, but we're not exactly sure. Okay? Well, this is an example of the screen as visualized by the participant in the experiment. They basically have access to they have all information about the whole history of this economy, both in graphical form as well as in table form. Now, I told you that expectations are important, and these models can be thought of as expectation feedback systems. Now, let me spend a few words about the nature of these expectation feedback. The feedback existing between expectation and realization can be of two types. It can be either positive, and that's when expected macro variables have a positive impact on realized macro variables, and then we have negative feedback when expectations have a negative impact on realizations. Now, of course, this is a two-dimensional system, so both expected future output and expected future inflation will have an impact on both realized output and realized inflation. So we're going to be looking at partial derivatives. It's a linear system, so all we need to know, all this information is included in the entries of this matrix M. Okay? So the nature of the feedback existing in this model is defined by the sign of the entries of this matrix. Now, given the structure of this model, all entries of this matrix are positive, with the exception of this northeast entry, and whether that's positive or negative, that depends on monetary policy. Okay, so let's see how. In this model, monetary policy is described by this simple Taylor rule, this simple interest rate rule, parameterized by this reaction coefficient phi pi, which, if you want, is kind of capturing the aggressiveness of the central bank. Okay? Now, depending on the value assumed by phi pi, we can distinguish different monetary policy regimes according to two things. First, whether the Taylor principle is satisfied or not, and that's basically, you only need to see whether this reaction coefficient phi pi is smaller or larger than 1. And by the way, that's all that matters for standard theory. Standard New Keynesian doctrine tells you that as long as that reaction coefficient phi pi is larger than 1, you should observe the inflation target as the unique equilibrium outcome. But then there is a second dimension which is neglected by standard literature, and that's the implied nature of expectation feedbacks in the system. Okay? So combining these two dimensions, we can distinguish three qualitatively different policy regimes. We have a first regime where the Taylor principle is not satisfied. So that reaction coefficient is smaller than 1 or equal to 1, and the system exhibits purely positive feedbacks. So all entries of that matrix M are positive. Then what do? We increase a little bit this policy parameter, this phi pi, and so we have a second regime where the Taylor principle is satisfied, but still the system exhibits purely positive feedbacks. Then we increase this phi pi a little bit further, and we have a third regime where, again, Taylor principle is satisfied, but now the system exhibits a mix of positive and negative feedback. Okay, so that northeast entry of matrix M is now negative.
So what is rho?
What is rho? Yes. Yeah, I didn't show you the specifics of this matrix M, but these entries are functions, of course, of the structural parameters of the economy, and rho is the time discount factor. Okay, so it's something smaller than 1. So, yeah, sorry about that. The treatments that we implement in the experiment, they basically mirror these different policy regimes. The only thing that we will be changing across treatments is the value of this reaction coefficient phi pi. Everything else is going to be exactly the same. Okay, so we're going to have a first treatment where phi pi is going to be equal to 1, so that the Taylor principle is not satisfied and the system has only positive feedback. Then we're going to increase phi pi a little bit more, so that we're going to have a second treatment where now the Taylor principle is satisfied. But still, we have purely positive feedbacks in the system. So what can we test by comparing the outcomes of these two treatments? What we can test is whether this Taylor principle is a sufficient condition to ensure convergence to the target. Why can we do that? Because the only thing that we're changing across these two treatments is whether this principle is satisfied or not, everything else being equal. Then we have a third treatment where we increase phi pi even further, so that now we have still Taylor principle satisfied, but now we have a mix of positive and negative feedbacks. What can we understand now by comparing the outcomes of treatment 3 versus treatment 2? Well, we can test whether the mere presence of some negative feedbacks in the system is enough to ensure convergence to the target. Again, well, if any, I don't want to spoil results here. Again, why can we do that? Because the only thing changing between these two treatments is the nature of the feedbacks in the system. Okay? And finally, we're going to have a fourth treatment, which belongs to the same policy regime of treatment 3, but we are going to increase this reaction coefficient phi pi even further. And by comparing the outcomes of treatment 4 and treatment 3, we can test whether this convergence, again, if any, is related to the strength of the negative feedback existing in the system. Why is that? Because that entry, that negative entry in that matrix M becomes more negative as phi pi increases. Okay? So here are the results. This is what happened in the experiment. Each of these graphs refers to the 4 different treatments. Each line in each graph refers to the dynamics of inflation in 6 different experimental economies, each of them composed of 6 subjects. The black dashed line represents the inflation target, that's 2% in this experiment. So let's see what happened. Treatment 1, what we observe is that in some economies we had coordination on explosive inflation paths, as well as coordination on some non-fundamental steady states. Is this surprising? Well, not really. That's also what standard New Keynesian doctrine tells us in determinacy of equilibrium. Okay, because the Taylor principle is not satisfied in this treatment. Let's see now what happened in treatment 2. Now, according to standard theory, because the Taylor principle is satisfied, we should observe convergence to the target. That's not what happened in the experiment. Again, in some cases we had coordination on explosive dynamics. In other cases we had coordination on some, in this case, almost self-fulfilling equilibria. To be fair, in one case we did reach the inflation target. That's the green economy over there, but that's not what happened in general. Okay? So again, this problem of multiplicity of equilibria appeared even in a situation where the Taylor principle is satisfied. So what we learn is that the Taylor principle is not a sufficient condition to ensure coordination of beliefs, of expectations on the desired equilibrium. Now let's move to treatment 3. What I would like you to realize is that quantitatively speaking, the difference between treatment 2 and treatment 3 is very small. So we're moving from a reaction coefficient phi pi of 1.005 to a reaction coefficient phi pi of 1.015. But qualitatively, the difference is huge because we're moving from a system that only exhibits positive feedbacks to a system that has a mix of positive and negative feedbacks. See what happened in the experiment. We do not observe anymore coordination on these explosive inflation dynamics. Oscillations, fluctuations of inflation are happen in a much narrower neighborhood of the inflation target, although we don't quite get there. You can see that graphically, but we also tested it statistically. These oscillations are not centered around the target. Then what we do in treatment 4, we increase this reaction coefficient phi pi even further, and what we observe is that indeed now the inflation target emerges as the unique equilibrium outcome. So what we learn is that negative feedback are stabilizing, positive feedbacks are bad, but negative feedbacks have to be strong enough in order to observe convergence to the target. Okay? Much more, so we propose a behavioral model of expectation formation that is able to explain the emergence of all different aggregate dynamics observed in the experiment, how through a process that we call self-organization of initial heterogeneous expectations on some common forecasting groups. I don't have time to go to the details, but you know, the nice thing about lab experiments is that you get clean data on expectations, and that's difficult to achieve in the field. So of course we stared at this data, and what we observed is that subjects in the experiment, they tended to coordinate on common forecasting strategies. Okay? However, these strategies were different across treatments. And in particular, what we observe is that in economies where we observe explosive inflation dynamics, subjects coordinated on trend following strategies. Okay, forecasting strategies that extrapolated past trends observed in the data. Now, the interesting thing is that the coordination on these kind of strategies only happens in the presence of positive feedbacks. And that's intuitive because let's think how positive feedbacks work. Well, if your expectations deviate from equilibrium or let's say from the target in one direction, say they are above target, realizations will be above target. Okay? So the signal that you get from the market does not really correct your expectation errors. On the other hand, when you have negative feedbacks, if your beliefs are above target, realizations will be below target. Okay? And so in the next period, you're going to revise your expectations, and this process will eventually converge. So the direct policy implication here is that indeterminacy of inflation equilibria can be eliminated through monetary policy. How? By manipulating the size of negative feedbacks in the system, preventing coordination of these destabilizing trend following strategies. Okay, so let me conclude. Well, basically I already said everything I wanted to say, but I really hope that I managed to show you how these lab experiments can be used as a complementary tool for policy analysis. Now, in relation to the specific policy problem at hand, what we learn from these experiments, which we didn't know from standard theories, is that the Taylor principle is in fact a necessary condition for convergence with target, but it is not sufficient. And what we learn also is that the emergence of the inflation target as an equilibrium outcome relates to the nature of the feedbacks existing between expectations and realizations. Okay? As I said, this was just an example of the kind of policy problem you can investigate using these tools, but in a series of research papers, we apply this methodology to a bunch of other policy questions. So I just want to mention a few examples. So we looked, for example, at the inflation output volatility trade-off. And what we learned is that this trade-off is non-monotonic, meaning that you can basically, through monetary policy, kill two birds with one stone, in the sense that you can achieve both a lower inflation and a lower output volatility simply by reacting up to a certain point to output gap fluctuation. So the sort of dual mandate that Andrea was referring to before. We also evaluated a recent policy proposal of increasing the inflation target, say from 2% to 4%, in order to insulate the economy from the risk of hitting the zero lower bound. And, policymakers were kind of skeptical about these proposals. I mean, I remember quotes from Bernanke, but also from Janet Yellen. They were skeptical on the grounds that if you do that, that's going to de-anchor your expectations, so you're going to have overshooting on the target. We investigated that in the lab, and the answer is, of course, it depends. It depends on the type of monetary policy that you use in the transition phase from one target to the other. We also investigated dynamics at the zero lower bound, as well as the role of fiscal policy, which unfortunately I didn't have time to talk to. But yeah, we also analyzed what's the role of fiscal policy in order to avoid and or escape liquidity traps. But I'm running out of time. I don't want to get the red card. So thank you very much for your attention.